Okay, so today what we're going to do is we're going to continue our look at algebra, right? So we're building the algebraic system. Some of this you've seen before, some of it may be new to you, but all of it needs to be repeated so that you can be successful. Remember, how do you learn something and really make it stick?
Practice.
Practice, exactly. The more times you're exposed to something, the better you get at it. So today we're going to talk about division. Last time we talked about multiplication. This time we're going to talk about some division. But before we do that, let's just review a little bit so that we remember a few things. Remember that in algebra, everything are made up of what? Terms. And all terms have how many parts? 4. Good. What's the first part? The sign. We haven't done much work with signs, but it's going to come. So we're going to practice that a little bit today. What's the second part called? The coefficient. Excellent. And that simply means the number part, right? Third part is the base, and that just means the variable, the letters. Yeah? Can you have more than one letter?
Yes.
Absolutely. And on every base, whether you see one or not, there is an exponent or an index, or another word for it is what? Starts with a P. Power. There you go. Doesn't matter. I don't care which word you use, whatever one you like. Okay? So those are the 4 parts of a term. And anytime we're doing any kind of mathematics with algebraic terms, we have to consider all 4 parts, right? And if you're going to consider all 4 parts, you're probably going to consider them in order, right? 1, 2, 3, 4, right? So keep that in mind as you go. One of the biggest problems that students have as they move forward in mathematics, and particularly when you're working with algebra, is that you get confused about what to do when. Well, do the first step first, and that won't happen, right? But you got to know what the first step is. So you have to study the rules and be aware of what the rules are. So let's just talk a little bit about what we did last time. We were talking about multiplying terms. Whoops, that's mut, not mult. Multiplying terms. Remember the first thing we did? What's the first part of a term? The sign. So the first thing you have to do is determine the sign. Okay? So let's just think about that really quickly, about those rules for signs when you're multiplying. When you're multiplying, if the signs are the same, in other words, they're both positive or both negative, what sign is your answer? Same equals positive, right? Because the 2 signs, so positive times a positive is positive, negative times a negative is a positive. So if the signs are the same, the answer is always what? Positive. Excellent. And these same rules, of course, are going to apply for division, which is what we do today, because division and multiplication are reciprocal operations. Now, if the signs are different, meaning that one of them is positive and the other one is negative, what do you think the answer is going to be? Negative. A negative, exactly. You'll get a negative answer. It's different to get a negative, right? So if the signs are different, you get a negative. Okay, so you always do the sign when? First. Because signs are one of the biggest problems in algebra. And it's usually not because that you don't know the rule. It's because you're too busy doing something else first, right? So get that out of the way first. Yes?
So if the signs are plus and minus, so it always be minus?
When you're multiplying or dividing, right? It depends on the operation, right? Totally different rules for combining. Yes?
Sorry, I'm just wondering if our test next time is going to be on algebra.
Absolutely. That's what we're headed for. So, okay. What's the second part of every term? The coefficient. Those are the numbers. And so that's the next thing you need to deal with. You would multiply the coefficients. Again, we're just reviewing what we did last time. So a 2 times a 5 is still a 10, just like it always was, right? Third part. It's up there. Anybody? Base or the variable. And remember, all we did was keep the base. It didn't change. Right? And Exponents, if we had any exponents on those, did we have any? No. But when you have more multiplication, more of something means you're doing what probably? Adding to. And that's exactly what you would do, is add the exponents. Now again, we didn't do that, but I think it's going to hurt you to go ahead and put it in your notes, and we'll be ready for it when it does happen. Okay? All right. We also talked a little bit about indices. What does a to the third power literally mean? Sure. A times A times A. Okay. Exactly. That means I have three a's all multiplied together. So we would never, in algebra, leave something like this. We would always write it in its simplest form. In other words, we wouldn't write repeated multiplication. We would write an index or an exponent, right? Okay, good. What if I had 3a times 4a? Can I multiply some of that stuff? Sure, Jasmine, what can I do? I'm sorry, your name's not Jasmine. A nook. Sorry. Lord.
You can ignore the a for now and just do 3 times 4 and then add all the a.
Exactly. So 3 times 4 is still going to be 12, just like it always was, right? Sorry, I know. But then I've got to take the a times a. A times a, I can't really multiply them together, but it'll be what? A squared. Be careful, the exponent of 2. A to the second power, or a squared, or a to the exponent of 2. Right? Looked good? Now, I haven't looked at the statistics to see if anybody has been working on this, but remember, I'm now posting assignments. That's what I expect for you to do for your homework. You will still get mathsmates because that's good to review you for things that we've done in the past. But the biggest focus now for your homework is the homework that I give you on Education Perfect. So if you have to do one instead of the other, this is the one to do. Now also remember that homework is not a part of your grade, but if you don't prepare for the test, how well do you think you're going to do on the test? Yeah. So the homework really is part of your grade. It's the exercise you do to get you ready, right? So make sure you're doing them. Also, I am planning, and this might not be as big a deal to y'all as it is for the year 7s, but I'm planning on the percentage of people who do their homework. Those people who do their homework, I'm going to be giving you credits for those as well. Okay? So at the end of a session, like at the end of an assignment, I'm going to look on there, see who did it on time, right? And who did it, and how many you got correct. And if you got them all correct and you did them on time, then I'll give you 10 points or 10 credits. Is that enough? 10, but 10 for every assignment. 10 for every assignment means a possibility of 30 or 40 a week. That's a lot, right?
You mean like 10 like in 1 week?
No. 10 per assignment that you do.
How long are the assignments?
They're not very long. They have like 8 or 10 questions here and there. Some of them have more, some of them have less. Also, there are some extension questions on some of them, not on all of them. But if you want to do the extension questions, you're more than welcome to. That's more for just you to work on, and then we'll talk about that a little bit more too, because I haven't really been doing anything for you guys, so I want to know about that as well. Okay, so everybody remember about multiplication? Well then, today what we're going to do is we're going to talk about what happens when you start to divide terms. Well, how many parts are there for a term? 4. What is the first part of a term? So what do you think you need to deal with first when you're dividing? The sign. Yeah. Do you see there's a pattern here, right? First things first. Now, again, just like with multiplication, if the signs are the same, your answer is going to be a what? be careful, positive. If the signs are different, the answer is going to be a negative. And that is only for multiplication and division. When we start talking about combining or collecting, it's totally different. Okay. What's the second part of a term? It's called the coefficient. Good. So what we'll do is we'll divide any coefficients. Now, does everything always divide? No. But if I say I have 8 divided by 4, what's that going to give me? 2, right? So I'm just going to get a plain old 2. But what if I have 3 divided by 5? Can I divide a 3 by a 5?
Yes, but you're going to
Not without getting a decimal, right? Okay, without turning it into a decimal. Can I actually do the division? No. So it's just going to stay division. And I forgot to write that down, but well, hold on just one second. Then what you're going to do is divide the variables. Now remember, in multiplication, I said keep the variable or keep the base. But in division, division is a way of getting rid of things, isn't it? Things go away when you're dividing. And so sometimes the variable is going to go away. And we'll talk about what that means. And I'm also going to show you a shortcut language that I hate. But they use it here. You'll see it in every math book, even all the way into college, into university level math books. They still use this same word that I hate. And the reason I hate it is because I see all the time, I see the trouble it causes, right? And so I'm going to show it to you because you're going to see it and you need to know what it is in the directions, but I want you to think about what it really means and what's really happening here, okay? Now, when we did multiplication, we said 4 times a, right? We don't like to write it like that. How could I write it? Instead of 4 times a, I could just write what? Just 4a. Sure, you bet. Well, division changes a little bit as well. If I want to say 4 divided by a, sometimes you will still see the division symbol. It still exists. But more often than not, instead of saying 4 divided by a with the division symbol, I would write it as a fraction.
Oh, no, that's annoying.
Nah, it's good stuff. Good stuff. The fraction bar is simply the division symbol.
Because the division symbol, hey, I just thought about that. The division symbol is like a line with the number on top and underneath.
Exactly. Look at it. A division symbol is a fraction, but with 2 dots on instead of it. Oops, sorry. Okay, so a division symbol is simply a fraction, but without any stuff in it, right? And actually, this format of writing division with a fraction came first. Somebody said, hey, you know what? We could just make a symbol out of that and make it look like this, and then my students won't be afraid of division because they won't think it's a fraction. But in algebra, we're lazy. We don't write anything we don't have to. Yeah? So it's always going to be written as a fraction bar. Also, something else. That is not a fraction. Not anymore. We were able to do that when you were in arithmetic because things stayed pretty simple. But literally in algebra, that slash is the symbol for or. What you've written here is 4 or a. Okay? So don't use that / for a fraction bar. And one of the main reasons for that is we need to be able to know exactly what we're dividing by. Say, for example, we had 4a divided by 3a minus 5. Now, if I did this, what does it look like the division part is? Just those first 2, right? But up here, there's a bracket around it, which means that I'm not only dividing by the 3a, but also by the minus 5, right? So this is not you can't write it like that. Instead, what you'll do is use the flat fraction bar, and then you can see that you're dividing by the entire thing, okay? Otherwise, it's very difficult to tell what you're dividing by. Yes? Well, it is actually because remember in the order of operations, they're telling you to do 3a minus the brackets first. But can you take a 5 away from a 3a?
No.
So you can't do it. They are actually asking you to do that first, but you can't.
Why can't you just go with the
Okay? Well, because one of them is an a term and the other is a constant. So they're not, what are they called? Like terms, right? Okay? Excellent. So be careful about like terms. Yes?
When you're dividing two fractions, can you put the division symbol, or would you just put the fraction by fraction?
If I was dividing two fractions, it would look like this. One fraction over another fraction with with this fraction bar just made larger. Okay? Good question.
Sorry,
Sure.
can you say how can you tell when you need to minus the 5 first?
Well, let's say you had the bracket like this.
I know, but like for the other one that you wrote, the equal semi-difference, how would you find out?
Well, because you couldn't actually do the division here because this one is an a term and this one is a number term, a constant.
And why is it in brackets?
Well, because they go together, they're one piece. You just can't go. They just can't be done. It doesn't just because you have a bracket doesn't mean you can always do the math in the bracket, right? But the bracket is there to hold them together. Okay, so think about it. If you went to the grocery store and you bought a whole cartload of stuff and you didn't have any bags to carry it in, now just because you bought a whole cartload of stuff, that's not the same stuff, is it? There's lots of different pieces, lots of different kinds of things, but you put them in a bag to hold them together, and that's all a bracket is doing. It's just holding it together. Okay? All right. Now, about brackets, though. Notice that this part was in a bracket, wasn't it? But when I wrote it over here, I didn't put the bracket around it, did I? But the bracket still exists. Every number in every fraction is always in a bracket. But since it's always there, we don't write it. So 1/2 really means 1 in a bracket over 2 in a bracket. They're always there. We simply don't write them because we don't have to. We get to assume they're there, right? Okay? Now, but it does do something very similar, very important though. Let's say that I had a fraction like this. Okay, let me erase those brackets. Because I know that the top of this fraction is in an imaginary bracket, that means that I have to do this first, no matter what. Okay? So if there's any math you can do in the top or any math you can do in the bottom, the numerator or denominator, you have to do that first. So let's change that a to a 2, just so I can demonstrate this a little better. Okay? All right. So say we have 8 minus 5, all divided by 2. Now, you may be tempted to say, oh, I can divide 8 by 2, right? But you can't. Because, remember, that even though you can't see it, that 8 minus 5 is in a bracket, which means I need to do that when? First. So it's really 8 minus 5, which is 3 over 2. Now can I divide by 3 by 2? So there's my answer. So always remember that even though you can't see it, there's always a bracket around the top and bottom of a fraction. Okay? Now, that's not really part of our lesson, but I'm just want to make sure that if any of you are weak in fractions, that we go through some of these things. All right, so let's look at some examples and show you what I mean, what we mean, and how to deal with some division. So what we're going to do is just go to Education Perfect. So in this lesson, you're going to learn how to simplify some division, because remember, in algebra, everything's about being as simple as possible. But also, I want you to remember that anytime you see that word simplify, that means do the order of operations. In other words, do the math But do it in the right order, right? Order of operations says I need to do what first? Brackets or parentheses, whichever you prefer. Exponents. Multiplication or division, and they're equals. You do them as you come to them left to right. And then finally, the last thing is addition or subtraction, which we call combining like terms now, right? Okay? So anytime you see that word simplify, it means do the math. And if you're going to do the math, that means follow the order of operations. Okay? So simplify is a word you're going to see a lot. Okay? All right, here we go. In algebra, you always write division as a fraction. Again, we're lazy. Don't want to write that division symbol. It makes it easier to simplify expressions that involve division, because what happens is, if you had this same problem using a division symbol, which one looks actually easier to work with? The one without all the stuff and the one that's not drug out sideways across a page. It's easier when things are right above each other to be able to work with them. So let's just look at this one. I don't want to go to the next page because it has the answer on it. Instead, I want us to divide this using the rules that we just talked about. Now, remember, I'm going to tell you the rule. We're going to do it piece by piece. So I want you to tell me which thing I need to look at. So you've got it in your notes. First of all, we're told to simplify this, which means apply the order of operations. And what operation is indicated here by this fraction bar? Division. Okay? And I'm not just dividing an 8 by 4 here, right? So I got to take it piece by piece. This is an algebraic expression. How do I know that it's algebraic? Because it's got letters in it. You bet. Good. All right. So that means I'm dividing terms. So what's the first part of every term? The sign. But if there is no sign, we assume it to be what?
Positive.
Positive. So it's a positive divided by a positive, so my answer is just going to stay positive, right? So do I even need to write the plus? No. But you know me, when I'm writing things on the board to show you, I'm going to write everything. So that way you can look back at it later and say, okay, why shouldn't that have been a whatever? All right. Then we're going to divide. What's the second part of a term? Coefficient. Well, the coefficient in the top is a what? But what is the coefficient in the bottom?
Nothing.
Yeah, well, there isn't one, but that means there is one. What is it? Right. If there is no number, you assume that number to be a what? A 1. Good. But so what is 3 divided by 1 going to make? 3. Right? So we've done the division with the coefficients. Now I'm going to divide with the variables, the base. But my first base is a to the second, right? A to the second literally means a times a, doesn't it? Is there an a in the bottom that I'm dividing by? Yes. So I'm dividing by a. And here's where there's a word that you've all heard, you've all used, everybody does it. Cancel. Have you heard that before? Ugh, I hate it. Because something divided by itself does not cancel. If you just had 2 divided by 2, does that cancel and now I don't have anything? No. But be careful. What's 2 divided by 2 make? 1. You don't say it. You don't do that with numbers. Then why do you do it with letters? It makes no sense. Letters are numbers too, aren't they? You just don't know what they are. So instead of cancel, anything divided by itself, number, letter, shoe, potato. Y'all love potatoes?
Potato.
Potato. There you go. Well, potato. All right. So what is R divided by R? Cancel? Nope. Anything divided by itself makes a what?
1.
A 1. The reason they say cancel sometimes is that you don't always have to write the ones. Because remember, all this stuff is stacked together by multiplication, right? So if you multiply by 1, you get right back to where you started from. So here, these two A's can divide away, but what do they really make? Nothing? They make a 1. But A times 1 is still just what? A. Okay? Now look at the last part. The last part is b divided by b. What does b divided by b make? 1. But do I need to write a 1 up here? No, because 3a times 1 is still just 3a. Okay? Now, if that makes a mess of your life, hold on a minute. We're going to do a lot more of them so you can practice it. But what I want you to avoid the thought of is a divided by a cancels. Because it doesn't. A divided by a makes a what?
1.
And most of the time you don't care because you don't need to write the 1. But what if it was the only number left? Then you have to have the 1, right? And I can't tell you how many tests I grade all the way through university level, and students do this number. Well, a divided by a, well, that cancels. And that's all I see. And it throws off your whole problem, right? As the problems become bigger and more complex, it's going to make a huge difference. All right. So let's see what they do to us next. Well, like I said, we're going to practice. Okay? So division, you can sometimes get rid of the variables, right? When you're multiplying, you just get more of them, right? But when you divide, you can eliminate them, can't you? So let's see how that works here. So look at this particular problem. It says we have 2r divided by r. So let's just go through the steps. First, I'll look at the signs. But do you even see any signs? No, that means they're positive, so who cares, right? Okay. Well, then I'm going to divide the numbers. But it's 2 divided by 1, or 2 divided by nothing, which just stays what? 2. I really do have a number down there. If you don't see a number, you assume it to be a 1. And then finally, r divided by r makes, say, what? 1. But do I need to write the 1? No, because it would be 2 times 1, which is still 2, right? So those r's became a 1, which I don't need. So that's why they say cancel, because they divide away. I'll let you get away with saying divide away, maybe. But I would really prefer you get in the habit of saying anything divided by itself makes, say, what?
1.
And do you always have to write the 1?
No.
No, because if you multiply by 1, you get right back to where you started from. So your completed answer is 2. So the variable term of r divided by itself made a 1. So there are no more r's left. Okay? So just 2. Okay? All right, let's look at this one. I don't know why they make it all interactive there. I can't. So you just hold on for a minute. So we have 7xyz divided by, you may remember what it was. XY? Oh, or XZ. I think that's what it was. Because the Z, they were the part that disappeared. Okay? So, again, fraction bar means to do what operation? Divide. So signs, there's a positive divided by positive, so it just stays positive, so we don't need a sign. 7 divided by nothing really means 7 divided by
1.
which is still 7. Excellent. X divided by itself makes a 1, but do I need to write a 1 if I already have a 7?
No.
Nope. Y, do you have any y's to divide by? No. So y divided by nothing just stays y. And z divided by z is 1. So do I need to write the 1? Nope. So there's my answer. Piece by piece. Yes?
So when you do x divided by itself, you don't have an x left over?
No, because x divided by itself turns into a 1. Okay? Not 1x, but just a plain old 1. Right? Remember this. We lose sight of what division means because we're so used to using the multiplication rules to do division. Right? We just reverse the multiplication rule. 18 divided by 4 is 4 because 4 times 4, 16 divided by 4 is 4 because 4 times 4 makes 16, right? So what we do is we think of division as being multiplication backwards, right? But it's not. Division means how many times can I fit this thing into this thing? So how many times can you fit something into itself? Once. Okay? Do you remember, maybe, because y'all are young enough, when you first learned division, did you have like beans or tiles or circles or something, and then you just separated them into equal piles, right? That's what I'm talking about. That's division, where you're taking things and you separate it into equal piles. And that's what division is. Then later, when she learned how to multiply, you started thinking of it as multiplication facts, right? So you've lost sight of what division means, and that's what causes a little trouble here. Okay? Let's look at some more. So 3a squared b divided by ab, we did that one. Be careful when you have squares. Your best bet, if you're nervous about it at all, is to simply expand it, right? And then you know that there are actually not one factor of a there, but two. Factor, what does that mean? Things that are multiplied together. So 2 times 3 equals 6. 2 and 3 are called factors because they're connected with what operation? So anything that's connected with multiplication is called a factor. So if you hear me say factor, that means things that are connected with multiplication. Okay? Good deal. All right. Let's see what's next. Okay? So once you've divided, canceled all the variables, I hate it, then you can move on to numbers, right? So when you're talking about numbers, not all numbers are going to divide out evenly. So what you can do is simplify the fraction by simply taking out common factors. So look, for example, at this problem. Now, I don't know why they give you this problem because you're not taking out common factors. You're just going to divide. So we have 4fg divided by 2fg to the second power, right? So 4 divided by 2. Can you divide a 4 by 2? Yes. You bet. What you get? 2. F divided by f makes a 1, but do I need to write the 1 if I already have the 2 there?
No.
Nope. Okay. And then here we have g, but it's not divided by a plain old g. It's divided by what? G squared. So that's the same as saying g divided by g times g. Do you agree? Now, one of these g's in the top and the one of these g's in the bottom will turn into a what?
1.
So we don't need it. But what do you notice? That we still have what?
A G.
And where is it? In the top?
Bottom.
It's in the bottom. So if it's in the bottom, it has to stay in the bottom. So it's not 2g is your answer, it's 2 over g. Okay, so pay attention to where they are when you're finished because you've got to make sure you get them in the right spot. Okay, so you see their answer. Fine, yes.
If it was like fg squared, like in brackets, would the answer still be 2g or would it be 2 over fg?
No, because the brackets wouldn't really have any meaning unless there's some math to do. Because remember, when you're simplifying, so say I have 2fg squared in brackets, right? Or, sorry, brackets. Can I do anything there with the 2 and the f and the g and the s and the square? No. Then there's no reason to have the bracket.
But what I'm saying is if you had 2fg squared in the denominator, because we're treating f as it's nothing to do with the g, and we're treating them separately, what if it was like fg divided by fg times fg?
So like you have fg divided by fg times fg?
Yeah.
Like that? Well, an f and an f can make a 1. A g and a g can make a 1. That means everything in the top is gone, so what do I have to have? In that case, I have to write the 1, right? And what do I have in the bottom? There you go.
That's what I'm trying to say. Because in the denominator, you've got 2fg squared. So how is that different?
Because it wasn't...
Brackets in there, like around fg squared?
Because remember when we talked about these, the only thing that's squared down there is the g, right? Not the f. There's 2 times f times g times g. So it's only that that's being squared.
What if I wanted to write 2 times fg times fg? Would I do 2 brackets fg squared? Also,
Yes. Right. That way you're squaring both of them. Okay. Absolutely. Okay. Now remember this. If there's bigger stuff in the bottom than there is in the top, then you're always going to be left over with something in the bottom, right? If there's more stuff in the top than there is in the bottom, then you're always going to be left with stuff in the top, right? Does that make sense? When there's more stuff wherever the more stuff is. So here we go. This is one in your homework. So very similar to what we did. Instead of writing it as QR squared, I could write it as 7Q what? All divided by R. Well, one of those R's is going to divide away and turn into a 1. But do I need to write the 1? No, because I have all that other stuff left. Doesn't cancel, really. It turned into a 1. I just don't need the 1 right now, right? But what if I had QR divided by QR? That divides away to make a 1, but since there's nothing left, what? I have to have the 1. And that's where the idea of cancel can cause you trouble. Yes?
But then if you do QR divided by QR, it would be 1 and another 1. So what does that equal up to? 2?
No. Because they're multiplied together, right?
Right.
It's Q times R divided by Q times R. So that one turns into a 1, that one turns into a 1, and 1 times 1 is still 1. Because they're always connected with multiplication.
And also, if you have something over on the top, would that go, would there be a line at the top, or would it go next to it? So, there's an R there, and at the top you have, a leftover R. Would you put it up to the 7?
Yes.
7R?
Absolutely. So here, what we ended up with at the end was 7QR. Okay. All right? Okay. All right, let's move on before we run out of time here, guys. I know division is so fun that you love it. So in this next section, what we want to do is we want to put it all together. And to put it all together, it's imperative that you remember order of what? Operations. If you get it out of order, then you're not going to be able to get the correct answer. So remember, multiplication and division, we can simplify those. And then adding and subtracting just means collecting like terms. Okay? So let's look at it. Always be sure. So let's look at this particular problem. It looks horrible, but it's not. It's just a matter of going step by step. I don't like the cross, so I'm going to use that. Now, our order of operations says I need to look for what first? Brackets. Do you see any brackets up here? Well, no, but there's some imaginary ones around the parentheses, but it's not going to matter. I mean, around the, fraction top and bottom, but it doesn't matter. What do you look for next? Exponents. Do you see any? Guys? All right. What do you look for next? Multiplication or division. And we say them at the same time because we do them from left to right, just like you're reading a book. Okay? So what's the first thing you see here? That's division, isn't it? Yeah. So let's do that first. So 10 divided by 5 leaves
10.
Whoa, be careful. 10 divided by 5 is 2. It's harder to do when you're thinking. It's okay. Now, I have a P in the top, but is there a P in the bottom?
No.
So P divided by nothing is just going to stay P. There you go. There's a Q in the top and a Q in the bottom, so those are going to divide away and make a what?
1.
But since I have 2P, do I need to write the 1?
No.
No. Very higher order thinking there, guys. I'm very proud of you for that. Okay? Now, what's the next operation symbol? Plus. Am I going to do plus yet?
No.
So I'm just going to drop it down. What operation is connecting these two things, though?
Multiplication.
Am I going to do that now? Yes. So what is 2P times 3 going to make? 2 times 3 is?
6.
And P times nothing just stays? So 6 P's. What operation is this?
Minus.
And do I do that yet?
Yes.
Well, not quite yet. I'm still looking at multiplication and division, right? But so I'm just going to bring that down. Okay? Now, the last thing I'm going to do is addition or subtraction.
Addition.
And so here I've got addition first. So what's 2P's plus 6P's going to make?
8P's.
but I still have minus p. So what's 8 p's minus p going to make?
7p?
Yeah, not 8, not 7, just plain 7. I'm sorry, not just 8, but 7 p's. Because remember, if you don't have a number in front of it, you assume one of them. So 8 of them minus one of them makes 7 p's. Be careful. When you subtract, that doesn't get rid of the variable, right? Just means you have less of them. What gets rid of the variable? Division, right? So your completed answer is 7p. Good. Yes, ma'am.
You know how you have the 10 on the top and 5 on the bottom? Do you always divide those numbers?
Yeah, always divide top by bottom. Always have to divide the numbers, just like any other division you've ever done. Okay? All right. Here we go. I want y'all to do this one. Get your paper out. Come on. We got to hurry because my battery's going dead. And it's almost time to go. So.
B divided by 5b is B divided by is -1.
Trick.
It's so dark in here. It's really dark.
Yeah, I left it dark because it's easier to see the screen. And I hate to close the windows. Well, but you can still finish. You can still do something with a b divided by 5b. Anybody? All right. This one's kind of tricky, and so let's go ahead and just work it. You want to? You got it? Okay, go. All right, I'll give you just a little bit more. We still have 5 more minutes, so hold on. Shh, guys. Go because I'm afraid we'll run out of time. This one's pretty evil, but it says to simplify. Simplify means apply the order of operations. So do you see any brackets?
No.
Next you look for multiplication or division. Do you see any? Yes, this is division, isn't it? So what I'm going to do is just bring down everything else. Okay? Is that a plus? Yeah, that's a plus. B divided by 5b. So there's no number divided by the 5, so the 5 is simply going to stay 5, right?
Yeah.
But b divided by itself is going to become a what?
1.
And I need the 1. Where do I need the 1? Because you can't have a fraction that doesn't have a numerator, can you?
No.
So that became 1/5. I knew you were going to hate that. Right? B's, it's division, so you should have done it first. Everything in the top divided away. If everything divides away, what does it always leave?
1. That's just evil.
It's evil. I know, I love it. But you're not going to forget it. You're not going to forget it as quickly now, are you? Yeah? All right, now am I done? No, 7b and 7b will make what?
14b.
Plus?
1/5. That's your answer.
Can I combine those?
No.
Because one is a b term and the other is a constant. Excellent. Okay? All right. Sorry to end off on that note, but yeah, there you go.